Ancient builders moved mountains of stone without any modern technology. This is the story of prehistoric surveyors, the masterminds who measured the impossible. By the end of this journey, you will understand the hidden genius behind monuments that defy simple explanation. How did they align entire structures with the stars using nothing but rope and stakes? And why did cultures across the globe develop eerily similar methods for moving massive stones? Their legacy forces us to rethink what we know about human potential. What does true ingenuity look like when stripped of all our modern tools? Göbekli Tepe rises from the Turkish plains as a haunting question carved in stone. This complex of massive, T-shaped pillars arranged in great circles was built over 11,000 years ago, a staggering 7 millennia before the Great Pyramid of Giza. Its creators were not an empire of pharaohs but hunter-gatherers, people we often picture as living hand-to-mouth. Yet they quarried, transported, and erected pillars weighing up to 20 tons. The scale is almost incomprehensible. To accomplish this, society itself had to be reimagined. This was not a casual weekend project. It required a sustained, coordinated effort spanning generations, a feat of planning and social organization that predates agriculture, let alone written language. What powerful motivation could compel such a monumental undertaking? The answer likely lies in the realm of the spiritual and the celestial. The precise arrangement of the pillars suggests they were more than a temple. They were a permanent connection to the cosmos, a calendar in stone marking the solstices and the cycles of the stars. This drive to build something eternal, to anchor their world to the heavens, reveals a profound ambition. It was an ambition for permanence, for precision on a scale that defies any simple explanation of primitive existence. The very existence of Göbekli Tepe forces us to ask not just why they built it, but how they even began to measure such a grand vision. The tools to translate that ambition from dream to reality must have been both ingenious and deceptively simple. The builders of Göbekli Tepe and other ancient sites worked with a toolkit that would seem laughably simple to us today. They had ropes made from plant fibers or leather, wooden stakes, and perhaps some polished stones or water-filled trenches. Yet with these basic elements, they achieved a level of precision that can still baffle modern surveyors. The true sophistication was not in the tools themselves, but in the deep understanding of geometry and physics applied to them. A knotted rope, for instance, was far more than a length of cord. By creating consistent knots at measured intervals, it became a calibrated instrument. Stretched between stakes and manipulated with practiced skill, it could be used to lay out perfect right angles through a process called triangulation. This method, based on the immutable properties of a 3-4-5 triangle, created a perfect square corner every single time. It was geometry made physical, a principle as true then as it is now. For establishing a level surface over long distances, they turned to one of the most reliable forces in nature, water. A simple trench filled with water, or later, a length of hollowed-out wood, became a universal water level. The surface of still water always finds true horizontal, providing an infallible reference line that could be transferred from one point to another, ensuring that massive stone platforms and foundations were laid perfectly flat. This demonstrates a profound truth that the most advanced engineering does not always require complex machinery. It requires a masterful grasp of fundamental principles. The real mystery then shifts from what they used to how they knew. What vast body of practical knowledge passed down through generations allowed them to see a measuring device in a puddle of water and a theodolite in a knotted string. This deep connection to the cosmos echoes across the globe, carved into the very alignment of stones. In the green hills of Ireland, the great mound of Newgrange stands as a silent testament to this celestial obsession. Built over 5,000 years ago, this massive tomb is more than a resting place for the dead. It is a carefully engineered instrument designed to capture a single, fleeting moment of light. For a few precious minutes around the winter solstice sunrise, a slender beam of sunlight pierces through a perfectly aligned roof box, flooding the inner chamber with a golden glow. This was not a lucky accident. It was the result of generations of patient, meticulous observation. Long before the first stone was set, early astronomers must have watched the horizon for years, marking the sun's slow journey south until it seemed to pause and reverse its course. They were mapping the sky itself, using simple markers of wood or stone to record the sun's most extreme rising and setting points. This knowledge, passed down and refined over centuries, was then translated into monumental architecture. The role of the shaman or the sky watcher was crucial, a person who could interpret the patterns of the heavens and guide the builders. For these societies, the sun's rebirth at the solstice was not just a calendar event, it was a spiritual necessity, a promise of returning life and order. The alignment of Newgrange fused the practical need for a calendar with a profound ceremonial purpose, binding the community to the cycles of the cosmos. This same impulse appears in the Americas, in the pyramids of the Maya, and in the deserts of Egypt. How could such distant cultures with no possible contact arrive at such similar ideas? The answer may lie not in a shared teacher, but in a shared human response to the sky above. When you look up, you see the same sun, the same stars, the same undeniable patterns. This unified worldview, where earthly construction mirrors cosmic order, suggests a fundamental thread in human thought. The precision we see at Newgrange points to a body of knowledge so vital, so central to their understanding of the world, that it was worth encoding in tons of stone for eternity. This geometric obsession finds its ultimate expression in the great stone circles scattered across the British Isles. Take Stonehenge, its massive sarsen stones arranged with a precision that seems to defy its own rugged appearance. The outer circle and inner horseshoe are not rough approximations, they are sophisticated geometric constructions. The builders were not just piling rocks, they were inscribing mathematical principles into the earth. Using nothing more than a central stake and a long rope, they could lay out a perfect circle. A single person would hold the rope taut and walk in a continuous path, scratching a flawless arc into the chalky ground. But the geometry goes far deeper than simple circles. The layout of the station stones at Stonehenge forms a perfect rectangle, and the diagonals of that rectangle create a series of Pythagorean triangles, the same 3-4-5 principle used at Göbekli Tepe. This reveals a foundational knowledge of geometry that was both practical and sacred. The key to this accuracy over such a vast area was maintaining constant tension on the rope. Any slack would introduce error, so they likely used teams, with one person holding the central peg firmly in place and another walking the circumference, keeping the rope stretched to its absolute limit. This created a fixed radius, guaranteeing a true circle every single time. The builders possessed an intuitive grasp of mathematics that would not be formalized in writing for thousands of years. For them, geometry was not an abstract theory confined to papyrus. It was a living, physical force. The circle itself was likely more than a convenient shape. It was a symbol of the cycles they observed everywhere, in the sun, the moon, and the seasons. The perfect, unbroken line had a profound symbolic meaning, representing unity, eternity, and the boundary between the earthly and the spiritual worlds. The harmony of the circle was a reflection of the cosmic order they sought to emulate. This drive to encode meaning into form raises a deeper question. What other impossible measurements did they achieve, and what tools could possibly suffice for the grandest projects of all? This geometric precision did not end at the boundaries of a single monument. Across the rolling hills of Britain, a far grander and more mysterious pattern emerges, one that connects sacred sites across vast distances. These are the so-called ley lines, straight alignments that seem to link ancient stone circles, burial mounds, and hilltop forts. The idea is captivating that prehistoric surveyors saw the entire landscape as a single canvas for a sacred geometry. Perhaps these lines marked ancient trade routes, guiding travelers from one known point to another. Or maybe they were pilgrimage paths leading the faithful on a spiritual journey across the countryside. Some even suggest they traced invisible channels of earth energy, felt only by those with ancient knowledge. The methods needed to establish such long-distance alignments are staggering to contemplate. It would have required teams of observers stationed on high ground, using smoke signals or reflected light to communicate, carefully aligning markers over miles of rugged terrain. Yet the evidence for their intentional creation is hotly debated. Skeptics point out that with so many ancient sites dotting the map, finding random straight lines that connect a few of them is statistically almost inevitable. It is like connecting random dots in a child's drawing and calling it a planned picture. But when you stand on a ridge and see a series of ancient monuments laid out in a perfect straight line ahead of you, the coincidence feels deeply unsettling. This raises a profound question about the prehistoric mind. Did they perceive the land in a way we have lost, seeing it not as a collection of separate places but as a unified, living whole? The possibility of such large-scale planning forces us to reconsider the very nature of their society. How did they communicate and coordinate over such vast distances? What shared belief system was powerful enough to organize the labor and knowledge required to imprint these lines upon the earth itself? But this geometric mastery of the land finds a perfect parallel in another fundamental element: water. While stones could be shaped into circles and lines, water offered something even more precious, a perfectly level reference that was both simple and infallible. In the ancient city of Mohenjo-Daro, part of the Indus Valley civilization, we see this principle applied with stunning sophistication. Their entire urban plan was built around a meticulously engineered drainage system. Every street was carefully graded, and every house was connected to a network of covered drains, all leading to central sewers. This was not haphazard construction. It required an intimate understanding of slope and elevation across the entire city, ensuring that wastewater would flow away consistently without ever backing up. The tool that made this possible was almost certainly the water level. A simple trench filled with water or a long, hollowed-out wooden trough would have given the builders a constant horizon line. By measuring down from the surface of the still water at different points, they could transfer a perfectly level benchmark over vast distances, guaranteeing that their canals and foundations were laid with precision. This was fluid dynamics in its most practical and essential form. They understood that water always seeks its own level, and they harnessed that natural law to build one of the world's first planned cities. This knowledge extended to the great canals of Mesopotamia, where managing the flow of the Tigris and Euphrates rivers was a matter of survival. To irrigate their fields, they needed to dig channels that maintained a very gentle, consistent slope over many miles. A slope too steep would erode the canal walls and drain too quickly. A slope too shallow would cause the water to stagnate and silt up. How did they measure this delicate gradient? They likely used the water itself, By observing the speed at which a floating object traveled down a test section of canal, they could estimate the flow rate and adjust the slope accordingly. This was a primitive but effective form of hydraulics, using the behavior of water to measure and control water. These early engineers were not fighting against nature, they were working in harmony with it, using its own properties as their most reliable tools. The reservoirs and aqueducts they built stand as monuments to this philosophy. They showcase a civil engineering prowess that relied not on complex instruments, but on a profound observation of the natural world. Water was more than a resource, it was a living blueprint. The principles of geometry and water leveling reveal a mind that saw the world in terms of physical space and alignment. But what happens when we add another dimension to their genius, the dimension of sound? Deep beneath the island of Malta lies the Saflieni Hypogeum, an underground labyrinth carved from solid limestone over 5,000 years ago. This is not merely a tomb or a temple, it is an acoustic chamber of astonishing complexity. Certain rooms within the Hypogeum are engineered to amplify specific sound frequencies with an almost supernatural clarity. A deep male voice chanting in the so-called oracle room can create a resonance that vibrates through the very stone, a sensation felt in the bones as much as it is heard by the ears. This was almost certainly not an accident. It was a feature. How could prehistoric builders, armed with little more than stone tools, have achieved such a precise acoustic effect? The process would have been one of relentless trial and error. A shaman or a designated soundkeeper would likely have stood in the chamber as workers painstakingly chiseled the walls, testing the resonance after each small adjustment. They were tuning the rock itself, shaping the hard limestone surfaces to reflect and amplify the sacred chants or drumbeats that were central to their rituals. Their measuring instrument was not a rope or a water level, but their own highly trained auditory perception. They could hear the shift in resonance as the room's shape changed, learning through generations of practice how the curvature of a ceiling or the angle of a niche could trap a sound wave and make it bloom. This suggests a multi-sensory design intention far beyond simple shelter. These spaces were meant to be experienced with the entire body, where sound could induce altered states of consciousness, unifying the participants in a shared, visceral vibration. The acoustic marvels of the Hypogeum point to a sophisticated, if intuitive, grasp of sound physics. They understood that sound was a physical force that could be shaped by stone, and they harnessed that force to create an atmosphere of profound power. This sensory layer of construction forces us to wonder, what other invisible forces, from sound to perhaps even light, did they learn to measure and control with nothing but their senses and their sheer, determined will? The echo in the Hypogeum was not just a physical phenomenon, it was a memory aid. In a world without blueprints or written formulas, the transmission of complex knowledge relied entirely on the human mind. Societies that built these impossible structures were not literate, but they were masters of information. They preserved vast libraries of data not on clay tablets, but in stories, songs, and meticulously crafted oral traditions. An apprentice learning to align a monument with the solstice sunrise would not be given a textbook. Instead, they would spend years memorizing chants that catalogued the stars, or stories where heroes walked paths that mirrored the geometric principles of a 3-4-5 triangle. The very rhythm of a song could encode the sequence for laying out a sacred circle, each verse corresponding to a step in the process. This was a living, breathing knowledge system, passed from one generation to the next through relentless repetition and ritual. We see this power of oral tradition in indigenous cultures today, where elders can navigate hundreds of miles of terrain by reciting songlines that describe every waterhole and mountain ridge in precise detail. For them, the landscape is a sung narrative. The prehistoric surveyors operated on a similar principle. The movement of the stars, the Pythagorean theorem, the correct slope for a water channel, these were not abstract concepts. They were woven into the fabric of their myths and their identity. To forget a single detail of the construction chart was not just a mistake, it was a spiritual failure that could jeopardize the entire community's connection to the cosmos. This required a social structure dedicated to preservation, where certain families or shamanic lineages were tasked as the keepers of specific knowledge. Their minds were the hard drives of their civilization, trained from childhood in sophisticated mnemonic techniques to visualize complex patterns and hold them forever. This challenges one of our most fundamental assumptions, that literacy is the foundation of advanced technology. These oral knowledge systems were not primitive precursors to writing. They were highly refined technologies of the mind in their own right, and in many ways they were far more durable. A clay tablet can shatter. A song, if valued enough, can live for millennia. This living library of oral tradition was not just for stories and songs, it also encoded the very standards of measurement. Across the scattered stone circles of Neolithic Europe, from the Scottish Islands to the French coast, a strange pattern emerges in the numbers. The diameters of the rings, the spacing between stones, and the dimensions of the burial chambers all seem to be based on a common unit, a length of roughly 2.72 of our modern feet. This is the controversial Megalithic Yard. The evidence comes from meticulous surveys of hundreds of sites. When you measure the circumferences of these circles, they often turn out to be whole numbers, like 100 or 200 of these proposed units. It is as if a single, invisible ruler was used from one end of the continent to the other. The probability of this happening by random chance, with so many independent sites reflecting the same base measurement, seems incredibly low. This suggests a shared technical language, a common standard that allowed different communities, separated by vast distances and perhaps even by language, to collaborate on a shared cosmological vision. But how could such a standard be maintained without a central government, without written records, and without any form of rapid communication? The answer likely lies in the human body itself. The most reliable portable standard any surveyor could possess was their own stride or their arm's reach. It is possible that the megalithic yard was derived from a specific pace, a rhythmic walk that produced a consistent length. Or perhaps it was defined by a pendulum, a stone on a string that swung a precise number of times over a known distance. A master builder could carry this standard within their own movements, teaching their apprentices the exact cadence of the step or the swing that defined the unit. This would explain the slight regional variations we find, as the average height of the local population or the specific materials used for a pendulum might cause tiny drifts in the standard over time and distance. Yet the core unit remains recognizable, a testament to a shared methodology. The existence of a megalithic yard implies something profound, a level of cultural exchange and shared purpose that we rarely attribute to these fragmented prehistoric societies. It suggests that the builders of these circles were not isolated tribes, but participants in a far-flung network connected by trade routes, pilgrimage paths, and a common school of thought. They were not just building local monuments, they were contributing to a continent-wide project, inscribing the same mathematical and astronomical principles into the landscape using the same invisible ruler. This shared metrology, this science of measurement, was the glue that held their grand collaborative vision together, allowing them to work on a scale that no single community could ever achieve alone. The same deep observation that tuned a room to a specific sound frequency also read the silent language of the landscape. Prehistoric surveyors were not just masters of geometry, They were expert ecologists, and the environment itself was their most dynamic blueprint. They understood that nature provided consistent, reliable markers if you knew how to interpret them. A particular species of tree, for instance, might only thrive on a specific type of soil or in a sun-exposed location. By using a lone, ancient oak on a ridge as a fixed sighting point, they could establish a long-distance alignment that remained true for generations. These living markers were more permanent and required less maintenance than any man-made post. Animal behavior offered another kind of calendar and compass. The seasonal migration paths of deer or bison created well-worn trails across the continent. It is no coincidence that many ancient earthworks and burial mounds are positioned along these very routes. The builders were not necessarily hunting from their sacred sites, but they were acknowledging and incorporating these natural highways into their cosmic design. The movement of the herds marked the turning of the seasons, a physical manifestation of the cyclical time they celebrated in their stone circles. To use these biological cues required a knowledge system built over centuries. An elder would know that when a certain shrub flowered on the southern slope of a hill, it was the signal to begin the solstice observations. They understood that the first morning frost in a particular valley meant the sun had reached its lowest point on the horizon. This was a symbiotic relationship with the living world. They did not simply conquer the land, they listened to it. They saw the flight patterns of birds, the growth rings of trees, and the behavior of ants as data points in a grand environmental survey. This holistic approach blurred the line between the sacred and the practical. A game trail was both a source of food and a spiritual pathway. A river's bend was both a water source and a celestial marker. The environment was not a backdrop for their constructions. It was an active participant, a co-designer in a project that wove human ambition seamlessly into the fabric of the natural world. The silent knowledge of the landscape was put to its ultimate test when it came time to move the mountains. Consider the Bluestones of Stonehenge, their smaller but no less significant cousins. These stones were not local. They were quarried from the Preseli Hills in Wales, a staggering 140 miles away. The sheer distance presents a puzzle that has captivated researchers for generations. How do you transport dozens of stones, each weighing up to 4 tons, across a terrain of rugged mountains, dense forests, and wide rivers without the wheel or domesticated animals for heavy hauling? The answer lies not in a single magical technique, but in a masterful application of physics and logistics. The most likely method involved a combination of sledges and rollers. A massive sledge, perhaps carved from a single oak log, would carry the stone, greased with animal fat to reduce friction. It would then be pulled by teams of people over a track of wooden rollers laid down in a continuous path. As the sledge moved forward, workers at the back would pick up the rollers it had just passed and rush them to the front, creating an endless moving road. This process required immense coordination, with rhythmic chanting likely setting the pace for the teams, turning back-breaking labor into a synchronized ritual. But the true genius of the surveyors was in the route itself. Before the first stone was ever pried from the quarry, scouts would have been sent out to map the entire journey. They were looking for the path of least resistance, a route that avoided the steepest slopes and the softest, most treacherous ground. Their most powerful ally was water. Whenever possible, they would have used waterways, lashing the stones to rafts or buoyant logs to float them along rivers and along the coast, dramatically reducing the labor required for overland haulage. This was not a blind trek, it was a carefully surveyed and planned operation. Modern experiments have put these theories to the test. Teams of volunteers, using only replica Neolithic technology, have successfully moved multi-ton stones over land and water. These trials confirm the methods are viable, but they also reveal the staggering human cost. Moving a single bluestone just 1 mile could require the coordinated effort of dozens of people for an entire week. This transforms our understanding of Stonehenge from a solitary monument into the culmination of a generational pilgrimage, a project that united communities across Britain in a shared Herculean endeavor. The successful transport of these stones stands as a testament to a spatial intelligence that could visualize a 140-mile-long project, breaking it down into manageable segments and overcoming every topographic challenge with nothing but human muscle and a profound understanding of the land. The journey of a single stone across 140 miles was guided by an even longer journey, the patient tracking of the sun and moon across the sky. The same minds that orchestrated these monumental logistics were also master timekeepers, and their most vital instrument was often nothing more than a stick planted firmly in the ground. This was the Gnomon, a simple shadow caster that functioned as a solar observatory. By watching the path of the shadow's tip throughout the day, an observer could mark true north at the moment of the shortest shadow, establishing a perfect meridian line. But the real magic was in the long game. Day after day, they would mark the shadow's length at noon. They would see it grow longer as winter approached and shorter as summer returned. Over the course of a year, the tip of the noon shadow would trace out a graceful curve, like a giant, invisible hyperbola on the earth. The two extreme points of this curve, the farthest north and south the shadow would ever reach, marked the solstices. This was the birth of the solar calendar. They did not need to understand the Earth's tilt. They simply needed to observe and record the pattern. In some places, we find notched stones or carefully placed cobbles that seem to align with these shadow paths, a permanent record of the sun's dance carved into the landscape. This knowledge was not abstract, it was the foundation of their survival. Knowing the precise date of the winter solstice told them that the days would now grow longer, a moment of profound hope. It signaled the time to prepare the soil or to organize the community for a major construction season when the weather permitted. The calendar dictated when to plant, when to harvest, and when to gather for the great ceremonies that united the people. Their cosmology was their planner and the sky was their clock. The moon presented a more complex puzzle. Its cycles are shorter and more erratic than the sun's, but no less important. Tracking the moon's phases required a different kind of marker, perhaps a series of posts or stones that lined up with its rising and setting points at key moments, like the full moon nearest the solstice. Over an 18.6-year cycle, the moon's path along the horizon swings from a major standstill, its farthest north and south, to a minor standstill, a much narrower range. Recognizing this long, slow rhythm represents a staggering achievement in long-term observation. It implies that knowledge was passed down with absolute fidelity for generations, with each new sky watcher adding their own observations to an oral archive that stretched back centuries. This was not a hobby, it was a sacred duty. The accuracy of these simple methods is humbling. The solar calendar derived from a gnomon can be accurate to within a single day, more than enough to synchronize the rhythms of an entire society. This patient, cumulative science allowed them to plan projects that would take longer than a single lifetime to complete. They could confidently lay out a temple, knowing that their grandchildren would be the ones to see its central axis align with a solstice sunrise they themselves had calculated decades before. Their genius lay in this fusion of the cosmic and the immediate, turning the silent motions of the heavens into the practical schedule for daily life and the bold blueprint for eternity. Some designs are so vast they can only be seen from the sky. High above the arid plains of Peru, the Nazca lines stretch across the desert, a gallery of geometric shapes and immense animal figures etched into the dark earth. From the ground, these are just shallow grooves, but from the air, they transform into a sprawling, purposeful canvas. The true engineering marvel lies in how these prehistoric artists, with no ability to fly, created such perfectly proportioned and symmetrical forms over miles of uneven, rocky ground. They began with a small-scale model, a detailed sketch laid out on a prepared flat surface. Using a consistent unit of measurement, perhaps a pace or a knotted rope, they would then transpose this design onto the landscape using a simple grid system. They established a central axis line, likely using the same rope and stake method for creating straight lines over long distances. From this central spine, they plotted a large grid of squares across the entire site, scaling up their original drawing one square at a time. A team at the central point would direct other teams at the grid points, using signal fires or reflected light to communicate, guiding them to scrape away the dark surface gravel to reveal the lighter soil beneath. The key to maintaining the design's integrity was the use of constant, fixed radii. To create a perfect spiral or a smooth curve for a monkey's tail, they would have used a long rope anchored to a central post, with a worker simply walking the circumference and scraping the earth along the path. This technique guaranteed that the curve was true, even if the artist could not see the whole shape taking form beneath their feet. The Uffington White Horse in England, a stylized figure carved into a chalk hill, presents a different challenge, that of perspective. This figure is meant to be seen from the valley below, not from directly above. Its creators had to compensate for the hill's steep slope, deliberately distorting the proportions so that the horse would appear correctly formed to a distant viewer on the ground. This required teams of surveyors stationed in the valley, shouting directions up the hill to the workers as they cut the turf, a slow, meticulous process of feedback and adjustment. The creation was only the beginning. The real test was preserving these figures against the relentless reclaiming force of nature. The Nazca lines have survived for millennia because of the unique, stable desert climate. The Uffington White Horse, however, requires constant renewal. For over 3,000 years, communities have gathered in a recurring ritual to scouring the chalk, cutting back the encroaching grass, and maintaining the brilliant white lines. This was not casual upkeep, it was a vital act of cultural preservation, a reaffirmation of identity etched into the very land they called home. These earthworks were more than art, they were a covenant between the people and the landscape, a statement of belonging so powerful that it compelled generation after generation to tend to a symbol they could only see in its entirety from a distant hill. They were merging engineering with a deep, spiritual need to leave a permanent mark, to declare, "We are here, and this land is ours." The landscape itself was a willing partner in these ancient projects. At Carnac in France, thousands of standing stones march across the countryside in eerie, parallel rows. The sheer scale is breathtaking, but the true genius is in their placement. These massive menhirs were not dragged onto a random, empty plain. Instead, the builders carefully positioned them to incorporate the existing geology, weaving their artificial lines seamlessly through natural outcrops of bedrock. A solitary, towering stone might be erected right beside a spring, a source of both physical water and spiritual significance. This was not a coincidence. It was a deliberate fusion of the human-made and the earth-given. The surveyors here displayed a profound skill in site selection, choosing locations where the natural terrain amplified their intentions. By building upon stable bedrock instead of soft soil, they ensured their monuments would resist sinking and shifting for millennia. The functional reasoning was matched by a deep symbolic one. A spring was more than just water, it was a portal to the underworld, a place of life and mystery. By aligning their stones with it, they were connecting their cosmic order to the very pulse of the earth. This required a nuanced geological understanding. They could read the land, identifying the most stable foundations and the most resonant acoustic spots. A stone placed on a specific type of rock might produce a distinctive sound when struck, turning the entire alignment into a giant lithic instrument. The choice of location was never an afterthought. It was the first and most critical act of construction. It meant seeing a future monument not as something to be imposed upon the world, but as something that grew organically from it. Why go to the immense effort of quarrying and moving a stone when a perfectly suitable natural pillar already stood in the ideal spot? This philosophy of incorporation reveals a world view where humanity was not separate from nature, but an integral part of its system. Their sacred geography was already written into the hills and streams, and their role was simply to highlight it, to trace the divine patterns they perceived with rows of enduring stone. This harmonious approach raises a final, compelling question about the legacy of these prehistoric surveyors and the silent, powerful knowledge they possessed. That same impulse to measure and map our world still beats at the heart of modern technology. The principles these ancient builders discovered through ropes and shadows are the very foundations of our global positioning systems. When your smartphone pinpoints your location on a map, it is using a form of triangulation that would be deeply familiar to the architects of Stonehenge. Instead of stakes and knotted cords, satellites high above the Earth act as the fixed points. Your device measures the tiny time differences it takes for signals to arrive from multiple satellites, calculating your position through a complex electronic version of the same geometric principle. The baseline measurements they established for their stone circles have evolved into the precise baselines used in geodesy, the science of measuring the Earth itself. We are still building upon their fundamental insights, just with a different set of tools. This enduring legacy is not just a historical curiosity. It is a powerful reminder that the most elegant solutions are often rooted in simplicity. Archaeologists now regularly employ these traditional methods to understand the past on its own terms. To accurately reconstruct a ruined site, they might use long ropes and water levels to verify the original alignments, discovering that these low-tech tools often reveal subtleties that modern laser scanners can miss. This hands-on approach forces a physical connection to the builders, a shared experience across millennia that illuminates the practical challenges they faced and overcame. Perhaps the most vital lesson for our time lies in their sustainable approach to engineering. They worked with the landscape, not against it, using natural forces like water and gravity as allies. In an era of climate change and resource scarcity, their philosophy offers a compelling blueprint. Instead of pouring energy into moving a mountain, they would find a way to build with the mountain. This mindset of low-impact, high-intelligence design could inspire a new generation of sustainable architecture, where we once again learn to read the land and harness passive forces. The genius of the prehistoric surveyor was not in the complexity of their tools, but in the profound clarity of their observation. They looked at a length of rope and saw a universe of geometric possibility. They gazed at a still pool of water and saw a perfect horizon. In reconnecting with their methods, we are not stepping backward, but reclaiming a deeper, more intuitive way of seeing our world and our place within it. Yet the sheer scale of these accomplishments inevitably invites more fanciful explanations. The idea that ancient aliens directed the construction of the pyramids, or that a lost super-civilization like Atlantis provided the blueprints, has become a persistent modern myth. These stories are captivating, offering a simple answer to a complex question, but they do a profound disservice to the very people they claim to celebrate. They replace the remarkable reality of human ingenuity with a science fiction narrative that robs our ancestors of their rightful credit. The truth, uncovered through meticulous archaeology, is far more impressive. Take the Great Pyramid of Giza, the long-held myth that such precision was impossible for Bronze Age Egyptians fueled speculation about extraterrestrial lasers or sonic levitation. Yet archaeological evidence paints a clear and compelling picture of a highly organized society. Worker settlements have been excavated near the site, complete with bakeries, infirmaries, and administrative buildings. Quarries show the precise tool marks of copper chisels and stone pounders. Transport ramps have been identified, their inclines and construction methods aligning perfectly with the known capabilities of the time. We even have a surviving papyrus logbook from a foreman named Murrah, detailing the transportation of limestone blocks by boat along the Nile. This is not the record of a mystified people awaiting alien instruction. It is the detailed account of a massive, state-run civil engineering project. Similar scientific analysis has demystified other sites. The massive stone moai of Easter Island were once said to have been walked into place by paranormal forces. However, experimental archaeology provided a much more human answer. Teams using only ropes and coordinated pulling have demonstrated how the iconic statues could indeed be rocked and walked upright across the landscape, a method that matches the oral traditions of the Rapa Nui people themselves. The evidence was not hidden, it was waiting to be tested. The fantastical claims tend to crumble under the weight of physical evidence. The notion that the Nazca lines were ancient runways for alien spacecraft ignores the simple fact that the desert floor is soft and unstable, completely unsuitable for landing any heavy object. They were clearly designed to be seen from the surrounding foothills, not from above, serving as ceremonial pathways for the people who made them. Why do these myths hold such power? They often emerge from a modern bias, a reluctance to believe that people without our technology could achieve such wonders. It is easier to credit unknown visitors than to accept the slow, grinding, generational effort of thousands of skilled workers. Dispelling these myths is not about stripping away wonder, it is about redirecting our awe to its proper source. The real story is one of profound human perseverance and collective intelligence. It is about the anonymous engineer who first noticed that a water surface is always level, and the generations of laborers who dedicated their lives to moving a single stone for a monument they would never see completed. This evidence-based appreciation allows us to honor these cultures for what they truly were, brilliantly innovative societies that solved monumental problems with the resources they had. Their legacy is not a mystery to be solved by aliens, but a testament to the boundless potential of the human spirit when united by a common purpose. By embracing the truth of their achievements, we connect more deeply with our own shared history and gain a humbling perspective on what is possible. Moving a stone is a feat of physics, but moving a society is a feat of leadership. The true foundation of these ancient wonders was not stone or rope, but a revolutionary social organization capable of uniting thousands toward a single, generational goal. The solitary shaman charting the stars or the master builder directing the rope teams held a unique and powerful status. Their specialized knowledge was a form of social capital, elevating them into a specialized class of architects and engineers. This was the birth of a professional elite, individuals who did not farm or hunt full-time but were supported by the community so they could focus entirely on the sacred geometry of construction. Their authority was rooted in a perceived connection to the divine, a necessary ingredient for motivating a population to undertake backbreaking labor for a project they might never see finished. This shift from egalitarian bands to more hierarchical structures, often called chiefdoms, was a direct response to the logistical demands of mega projects. A simple village could build a hut, but only a complex society could build a pyramid. The case of Easter Island offers a fascinating, albeit cautionary, example. The creation and transport of the massive Moai statues was likely driven by a powerful clan-based rivalry. Each tribe, under the direction of its own chief and master carvers, competed to erect larger and more impressive figures, believing the statues channeled spiritual power or mana to protect their community. This competitive spirit fueled a burst of incredible productivity, a testament to how social dynamics can drive technological and artistic achievement. Yet it also reveals the fragility of such systems, where the very drive to build monumentally could strain an island's resources to the breaking point. In stark contrast, the pyramids of Egypt represent a model of absolute state-controlled organization. Here, the project was not a matter of tribal competition but of national ideology. The pharaoh was a god-king, and his tomb was a machine for eternal life, central to the identity of the entire civilization. This centralized authority could mobilize a staggering workforce, not through slavery as often depicted, but through a form of conscripted labor where farmers worked during the Nile's flood season. They were housed, fed, and organized into specialized crews with names like the Friends of Khufu. The surveyors and architects in this system were high-ranking priests and officials, their knowledge seamlessly blending astronomy, mathematics, and theology. Their precise measurements ensured the pyramid's sides aligned with the cardinal directions and its slopes reached for the sun god Ra. This was not just construction, it was a national ritual, reinforcing the power structure with every perfectly placed block. The success of these projects, whether driven by rivalry or royal decree, hinged on a shared belief system that made the immense effort meaningful. The labor was not seen as a burden, but as a duty to the gods, an investment in cosmic order, and a source of communal pride. This intertwining of technical skill and social cohesion reveals a profound truth. The ability to measure the land and the heavens was only half the equation. The other, more crucial half was the ability to measure and mobilize the human spirit. The silent coordination required for these vast projects extended far beyond any single valley. Across entire regions, from the chalk downs of England to the highlands of Scotland, sacred sites display uncannily similar alignments to the solstices. How could separate communities, separated by miles of dense forest and rugged hills, possibly achieve such consistency in their celestial orientations? The answer lies not in a central command, but in a web of interconnected knowledge. Shared ceremonial cycles were the invisible calendar that synchronized their efforts. Imagine a time when the summer solstice was not just a local event, but a continent-wide pilgrimage. People would travel for weeks along established trade routes, gathering at a major site like Stonehenge. There, master builders from distant communities could exchange techniques, compare observations of the stars, and agree upon the precise astronomical principles that would guide their own local constructions. A master surveyor from the north might demonstrate the exact knot pattern for a 3-4-5 triangle rope, while a sky watcher from the coast shared a new method for pinpointing the lunar standstill. These gatherings were living conferences where the sacred and the technical were one and the same. The trade networks that moved precious stones like amber and jade also moved something far more valuable: ideas. A merchant carrying obsidian from one village to another would not just be bartering for goods, he would be a courier for celestial data. He might carry a carefully notched tally stick that recorded the sun's midwinter setting position, or a standard length of cord, a physical manifestation of the megalithic yard, to ensure that a new stone circle would be built to the same cosmic scale as those in distant lands. For long-distance alignment of sites, simpler methods were essential. To ensure two burial mounds on opposing hilltops were placed on the same solstice line, teams would have used signal fires. A plume of smoke by day or a beacon of flame by night, visible across many miles, could guide the placement of a marker stake with astonishing accuracy. A team on one hilltop would light their fire when the sun touched the horizon, and a watching team on the next hill would immediately plant their stake in line with the fire and the celestial event. This was a slow, patient process of call and response across the landscape, a conversation of light and shadow that stitched the sacred geography together. This level of coordination paints a picture of a deeply interconnected prehistoric Europe, not a collection of isolated tribes. It suggests a shared cosmological vision so powerful that it transcended local dialects and loyalties. The consistent orientation of tombs and circles was a conscious choice, a way of embedding their communities into a single, harmonious cosmic order. They were building individual notes in a continent-wide symphony, each one perfectly tuned to the same celestial key, creating a resonance across the land that echoed their unified understanding of the universe. The tools of the surveyor were not always made of stone. Some of the most vital instruments were spun from fiber, tied with knots, and woven on looms. For generations, the narrative of prehistoric construction has been dominated by figures of male laborers and master builders, but a closer look at the evidence suggests a far more collaborative picture. The hands that measured the world may have also been the hands that held the spindle. Consider the humble cord. The creation of strong, consistent rope was a sophisticated craft, one often linked to women through both burial goods and ethnographic studies. In many traditional societies, women were the primary rope makers, twisting plant fibers or leather into the durable lines that would become the surveyor's calibrated measuring tape. The very act of creating a uniform cord required an intuitive grasp of tension, consistency, and standardized length, a form of practical mathematics. This knowledge did not exist in a vacuum. The same cognitive skills used in weaving complex patterns on a loom, a traditionally female domain in many cultures, translate directly to spatial reasoning and geometric understanding. Laying out the grid for a textile pattern is not so different from plotting the points for a stone circle. Both require an understanding of symmetry, proportion, and the relationship between parts and the whole. A woman weaving a basket with a precise, repeating diamond motif was, in a very real sense, practicing applied geometry. Her expertise in creating patterns from memory could easily have informed the larger-scale patterning of the land. Beyond cord and cloth, women's roles as herbalists and land managers provided another layer of essential knowledge. In many indigenous societies, women were the primary botanists, possessing an intimate understanding of soil quality, plant growth, and the subtle markers of the landscape. This ecological wisdom would have been invaluable in selecting stable sites for construction, identifying the best materials for tools, and even using specific plants whose growth patterns could act as seasonal calendars. The placement of a sacred spring or a particular ancient tree, often features incorporated into megalithic sites, might have been guided by this deep, place-based knowledge held by women. Archaeological evidence supports this more inclusive view. Burial sites from Neolithic Europe sometimes contain women interred with measuring rods, polished stones that could have been used for smoothing and aligning, or miniature looms. These are not the grave goods of passive observers, but of individuals with status and technical skill. In some North American mound-building cultures, women are believed to have held roles as ritual leaders and clan mothers, directly involved in the planning and consecration of earthworks. Their authority over social and spiritual geography would have naturally extended to its physical layout. To ignore these potential contributions is to see only half the blueprint. The story of early innovation is not a solo performance but a chorus of many voices, each bringing a different kind of genius to the monumental task. It was a collaboration between the strength that moved the stones and the knowledge that told them exactly where to go. This reimagined past does more than just add women to the picture. It reveals a richer, more complex tapestry of human ingenuity, woven from countless different threads of experience and expertise. The true test of these ancient methods comes not from textbooks, but from mud, sweat, and rope burns. Experimental archaeology puts theory to the ultimate test by recreating prehistoric surveying and construction using only the tools and materials available at the time. One of the most famous modern experiments involved moving a concrete replica of one of Stonehenge's massive sarsen stones. Researchers used a simple wooden sledge, greased with animal fat, and placed it on a track of freshly cut log rollers. A team of volunteers then pulled on long ropes, heaving in unison. The initial movement was agonizingly slow, but once the sledge began to glide on the slick, rolling logs, the stone could be moved several feet with each coordinated pull. This hands-on work revealed details no blueprint could ever capture. The type of wood for the rollers was critical, as green, freshly cut timber was more flexible and less likely to splinter under the immense weight. The rhythm of the work was everything, requiring a chant or a drumbeat to synchronize the team's efforts, turning individual strain into a shared, rhythmic motion. These experiments proved the methods were not just possible, but also highlighted the sophisticated logistics behind them. Moving a single stone required a well-organized society where some people cut wood for rollers, others prepared food for the workers, and skilled rope makers ensured the lines were strong and uniform. The knowledge gained is profoundly physical. You learn that a rope, when wet, can stretch and change its measured length, a tiny variable that could ruin the alignment of an entire monument over a long distance. You discover that a water level is incredibly accurate, but a sudden wind can ripple the surface and distort your reading. These are the practical realities that ancient surveyors had to master through a lifetime of experience. This experiential approach often uncovers elegantly simple solutions that pure theory misses. For instance, researchers attempting to carve the hard stones at Göbekli Tepe found that using simple flint tools was not only possible, but that the stone could be shaped more effectively by repeatedly heating it with fire and then cooling it rapidly with water, causing it to flake away. This thermal shock technique would have been a brilliant adaptation, turning fire itself into a precision tool. The greatest insight from these reconstructions is a newfound respect for the embodied intelligence of the builders. Their knowledge was not just in their minds, but in their muscles and their senses, a deep understanding of friction, leverage, and material behavior gained through generations of trial and error. By physically replicating their work, we are not just rebuilding ancient structures, we are rebuilding a connection to the ingenious minds who first conceived them. Every measurement was a message, and every number held a secret power. For these ancient builders, the act of laying out a circle with a rope was not merely a technical procedure, it was a ritual invocation of cosmic order. The perfect, unbroken line of a stone circle was a physical echo of the cyclical nature of life, death, and rebirth they observed in the seasons and the stars. This is where the practical science of the surveyor fused completely with a sacred, symbolic language. We see this profound numerology etched into the very bones of their monuments. Consider the great passage tomb of Newgrange. Its inner chamber is not a random shape, but a precise cruciform design, a layout repeated across many such tombs. This was not just an architectural choice, it was a spiritual one. The cross shape likely represented the four cardinal directions, a symbolic mapping of the entire world centered on the chamber where the remains of the ancestors rested. The numbers were just as intentional. the number of standing stones in a circle, the counts of posts in a wooden henge, or the dimensions of a burial cist often seem to recur in patterns. The number 3, for instance, appears again and again, perhaps symbolizing the fundamental stages of life or the 3 realms of earth, sky, and underworld. These were not random quantities, they were chosen with purpose, embedding the monument with a specific spiritual resonance. This intuitive grasp of powerful proportions extended to shapes as well. While they may not have formally written out the equation for the golden ratio, they certainly understood its aesthetically pleasing and harmonious qualities. The proportions of certain stone rectangles and the spirals carved into passage graves like those at Newgrange often approximate this famous ratio. They could generate these shapes using their simple ropes and stakes, discovering through practice that certain geometric relationships produced a sense of balance and beauty that felt inherently right, even divine. This was math felt in the bones before it was ever codified in the mind. At the heart of this fusion was a worldview where nothing was separate. A unit of measurement was not an abstract standard. It was a length derived from the human body, the stride of a king or the forearm of a master builder, connecting the work directly to humanity. The circle was not just a convenient shape, it was the sun and the moon. The act of ensuring a foundation was level was not just about stability. It was about creating a microcosm of the flat earth beneath the dome of the sky. In their hands, a measuring rope was a tool for building a temple, and that temple was a model of the universe. The precision of their work was an act of devotion, a prayer made solid in stone, ensuring that human society remained in harmonic alignment with the eternal laws of the cosmos. This deep, symbolic coding of the landscape leads us to a final, haunting question. What happened when this ancient knowledge, this sacred science, was finally lost to time? The climate itself became a tool the builders had to learn to read. As the last ice age retreated, the world warmed, sea levels rose, and forests spread across former tundra. This great Neolithic transition, the shift from hunting to farming, was not just a change in diet, it was a revolution in how humans related to the land, and it demanded new forms of measurement. The very ground beneath their feet was changing, and their sacred architecture had to adapt. At the famous site of Skara Brae in Scotland's Orkney Islands, a village was buried by a violent sandstorm, preserving it perfectly for millennia. The builders did not abandon their homes, they reinforced their stone walls, building higher and stronger against the encroaching dunes. Their entire settlement, with its stone beds and drainage channels, was a masterpiece of adaptation to a harsh and shifting coastal environment. This was not a one-time event, it was a continuous process. Across Europe, ceremonial sites show evidence of being modified over centuries. A wooden henge might be replaced by a stone circle, its alignment subtly adjusted as centuries of observation refined their understanding of a slowly shifting solar calendar. The reason for these changes was often climatic pressure. A community living on the coast might watch as rising seas slowly swallowed their ancestral fishing grounds. Their response was to build a new ceremonial center further inland, carefully replicating the solar alignments of the old site, using their surveying skills to transplant their cosmic connection to safer ground. In the deserts of the American Southwest, the ancestral Pueblones faced a different challenge: prolonged drought. Their great cliff dwellings at places like Mesa Verde were not their first homes. They were a late adaptation, a move from open valleys to more defensible and sheltered canyon alcoves, where water was easier to collect and the rock provided natural insulation from the heat. Their earlier structures, great pit houses and kivas on the mesas above, were gradually abandoned as the rains failed. Yet even in their new vertical cities, they maintained their precise astronomical alignments. A shaft of light would still strike a specific spiral petroglyph on the summer solstice, a testament to their unwavering commitment to celestial timekeeping, even as their entire way of life was forced to change. This adaptability reveals a deep resilience. These societies were not rigid, they were dynamic, learning to read the signs of environmental stress and pivot their grand architectural plans accordingly. Their greatest construction was not any single temple, but a sustainable relationship with a changing world. They understood that to build for eternity, you had to be willing to move with the earth. The grandest visions can be stopped cold by a single, unseen crack in the stone. Scattered across the globe are the skeletons of ancient ambition, monuments that were never finished, offering us a rare and honest look at the limits of prehistoric engineering. In the quarries of Aswan, Egypt, the unfinished obelisk remains fused to the bedrock, a project abandoned when a fatal flaw fractured the granite. This was not a failure of will, but a miscalculation of material. The builders had mastered the technique of carving trenches around the intended shape, and then driving wooden wedges into channels, soaking them with water so their expansion would crack the stone free. But they could not see the hidden weakness running through the rock, a lesson in the unforgiving nature of their materials. Had it been completed, it would have been the largest obelisk ever erected, a towering needle of stone. Its failure tells us that their knowledge, while profound, was not infallible, that the earth itself could refuse to cooperate with even the most skilled surveyor's plan. Across Europe, the story repeats in a different form. At sites like the Ring of Brodgar in Orkney, the circle is incomplete, with empty sockets waiting for stones that never arrived. Was this a project halted by a changing climate, as shorter growing seasons forced the community to focus on survival rather than ceremony? Or did social conflict erupt, a rivalry between clans that dissolved the shared purpose needed to haul the final monoliths into place? Perhaps the master builder died, taking with him the precise knowledge of the intended alignments, and no one else possessed the authority or the understanding to complete his sacred geometry. These abandoned sites reveal the fragile social and ecological contracts that underpinned these massive endeavors. They needed stable leadership, consistent resources, and a peaceful, coordinated population. A single drought, a war, or a plague could unravel generations of work. The vulnerability of these projects makes their successful counterparts all the more astounding. When we see the perfection of a completed Stonehenge, we are not looking at an inevitable outcome, but at a narrow victory against a host of potential disasters. Each finished monument is a testament to a society that managed to hold itself together long enough to see its cosmic blueprint realized, a fleeting moment of harmony between human ambition and a capricious world. A nearly identical geometric impulse appears halfway across the world in the great earthworks of North America. The Hopewell culture of the Ohio River Valley built vast, precise enclosures out of earth, forming perfect circles and enormous squares that align precisely with the lunar cycle. They achieved this not with stone, but with baskets of soil, painstakingly carried and piled to trace lines across the landscape. Just like the builders of Stonehenge, they used a central stake and a long rope to lay out their perfect circles, scratching the geometry into the earth before the first basket was ever filled. This was the same solution born from a separate continent. Meanwhile, in the high Andes, the Inca were master surveyors of a vertical world. They terraced entire mountainsides for agriculture, building with such precision that their stone walls, fitted without mortar, withstand colossal earthquakes. Their tool was the quipu, a complex system of knotted strings that recorded numerical data, a portable, tactile record of measurements, taxes, and perhaps even celestial cycles. They did not need the wheel because their surveying adapted to the terrain. creating stairways and suspension bridges that conquered the most impossible peaks. In Asia, the ancient Chinese developed their own sophisticated surveying tools, like the yuanji, a primitive compass used for aligning cities and tombs in accordance with the principles of feng shui. Their cities were laid out on a strict grid oriented to the cardinal directions, a practice that mirrors the cosmic order sought by the Egyptians. The parallels are undeniable. A culture in Turkey uses a knotted rope to create a perfect right angle, while another in Peru uses the same 3-4-5 triangle principle to square the corners of its monumental architecture. This is not evidence of a lost global teacher, but of a shared human cognitive toolkit. When faced with the same fundamental problems of aligning a structure to the stars, creating a level foundation, or measuring a vast distance, the human mind, regardless of location, tends to converge on a set of elegant, practical solutions rooted in the immutable laws of geometry and physics. Yet the differences are just as telling, shaped entirely by local environment and belief. The Egyptians had an abundance of flat desert and brilliant stars, perfect for celestial alignment, so their pyramids point precisely north. The Maya, surrounded by dense jungle, built towering pyramids to see above the canopy, aligning them with the dramatic zenith passage of the sun, a unique concern in the tropics. The builders of Carnac in France used the local granite, while the Hopewell used the earth beneath their feet. The materials changed, but the underlying drive to impose order on the chaos of nature remained a constant. This global perspective shatters the old idea of a single cradle of civilization. It reveals a world flickering to life with multiple, independent centers of genius, each discovering the same profound truths about their universe through their own unique lens. The instinct to measure, to map, and to build in harmony with cosmic forces appears to be a universal human trait, a deep-seated part of our shared inheritance that compels us to leave a measured mark upon the world. The silent language of prehistoric geometry is now being decoded with tools these ancient builders could never have conceived. Light detection and ranging, or LiDAR, is perhaps the most revolutionary. This technology uses laser pulses fired from an aircraft to map the ground surface with stunning precision, digitally stripping away forests and undergrowth to reveal the hidden bones of the landscape. In Cambodia, LiDAR scans unveiled a sprawling, invisible city around Angkor Wat, a complex network of canals and roads that rewrote the history of the Khmer Empire. Across Central America, it is exposing vast ceremonial centers and interconnected Maya settlements, showing that what we once thought were isolated temples were actually parts of immense, carefully planned urban grids. This allows us to see the land as the original surveyors saw it, revealing the grand, holistic design that was always there, just hidden from view. But technology is also peering into the lives of the individuals who held the ropes. Isotope analysis of skeletal remains can now trace a person's lifetime movement from the chemistry of their teeth and bones. We can identify an individual who grew up in one region but was buried in another, proving the long-distance travel of skilled workers or perhaps even master builders who carried their knowledge across continents. Ancient DNA is revealing the familial relationships within burial sites near monuments, showing that these projects were often family affairs, with specific lineages dedicated to the craft of construction for generations. These are no longer anonymous laborers. They are becoming people with histories, migrations, and social ties. So what grand mysteries remain just beyond our grasp? The origin of the megalithic yard is a tantalizing puzzle. Was it truly a universal standard? And if so, what precise natural phenomenon, what specific human pace or pendulum swing defined its exact length? Future research combining precise archaeological data with advanced statistical modeling might finally pinpoint its source. Another profound question involves the very transfer of knowledge. We understand the principles of the 3-4-5 triangle, but we have yet to find the teacher's manual, the physical training aids used to pass this sacred geometry from one mind to the next. Perhaps a future discovery will unearth a set of carefully knotted cords, a prehistoric surveyor's kit preserved in a peat bog or an arid tomb. The greatest secret still buried is the complete story of the first visionaries. Who was the individual who first laid out the central axis of Göbekli Tepe, and what words did they use to convince their community to embark on an 11,000-year project? The stones have kept their silence for millennia, but with every new technological eye we turn upon them, they are beginning to whisper. Their legacy is not one of forgotten tools, but of an enduring mindset, a testament to the power of the human spirit when it confronts the impossible. We have walked with these ancient surveyors, from the first stone circles laid out with knotted rope to the celestial calendars carved into the sides of pyramids. Their genius was not in complex machinery, but in a profound clarity of observation, seeing a perfect level in a pool of still water and a cosmic blueprint in the dance of the stars. They remind us that true innovation begins not with what you have, but with how deeply you see the world around you. As we navigate our own complex challenges, from a changing climate to resource scarcity, their example offers a powerful compass. They worked in harmony with the landscape, using gravity and natural forces as their allies, building sustainably for a future they would never see. Their greatest monument is not any single stone, but the timeless lesson that collaboration, patience, and a deep connection to our environment can unlock solutions we never thought possible. We are left with a sense of profound wonder, not just for what they built, but for the quiet, determined intelligence that made it all happen. Which of their creations speaks most deeply to you? Is it the silent, sun-pierced chamber of Newgrange, the mathematical perfection of Stonehenge, or the sprawling, sky-bound lines of Nazca? Share your thoughts on the prehistoric mystery that captures your imagination, and join us as we continue to uncover history's greatest enigma.